Welcome to Cookie's Maths and Science Hub. Today we'll be exploring quadratics. So, what is a quadratic? Quadratics are equations where the highest possible power is 2. Remembering that powers are our exponentials. So for example, x squared is a quadratic because it is x to the power of 2. Whereas x to the power of 3 or x cubed is a cubic. We write out our quadratic equations in the standard form of a multiplied by x squared plus b multiplied by x plus c, where a, b, and c are known numbers, and x is our unknown. We draw them on Cartesian planes as parabolas, which looks like the curve in the diagram here. Important parts of a quadratic are its roots, or x values, its y-intercept, where it crosses the y-axis, and its vertex, which is where that parabola turns around. We will be discussing how to factorize equations and draw equations in a number of different ways. But before we do this, it's important to know how to solve equations in our final step. We do this by using what's called the null factor law. This law states that if the product of two numbers is 0, then either or both of the two numbers is 0. For example, if we had a times b equals 0, then a would equal 0 or b would equal 0. Looking at some actual examples with numbers now, if we had 4 times a equals 0, because we have the 4, we must know that therefore a is equal to 0. One that's more common in our quadratics is something like this, where we'd have 5 plus q times a equals 0. Therefore, in this situation, either q is equal to -5, as if q is equal to -5, it makes that first part of the sum 0, or a is equal to 0 by itself. This next one is more of a standard form that you'll see for quadratics. We have 4 plus x multiplied by x take 7 equals 0. In this situation, we need one of those two terms, so either the first bracket set or the second bracket set to equal to 0. So, in this situation, therefore, either x is equal to -4, as 4 plus -4 gives 0, which would fulfill the null factor law, or x is equal to 7, as 7 subtract 7 is equal to 0. Either of those options are true for this equation. Now, this video is quite chunky, as there is a fair bit to cover in quadratics. As such, I've made this slide here to highlight the times where different matters are discussed. The 4 main things we'll be covering in this video are factorizing quadratics, factorizing by completing the square, how to use the quadratic formula, and drawing quadratics on a Cartesian plane. As was mentioned at the start of the video, the standard form of a quadratic is x squared plus bx plus c. To factorize quadratic equations, you need to find factors of c that add together to give b, and we'll call these factors y and z. So in this case, we would have x squared plus, in brackets, y plus z x plus yz equals x plus y multiplied by x plus z. Now I know this can sound confusing, but hopefully it'll make sense after we go through a few examples. So, let's look at our first. We're asked to factorize x squared plus 7x plus 6. So we know our b value is equal to 7 and our c value is equal to 6. So looking at our factors of 6, we have 1, 2, 3, and 6. Now we need to pick 2 of these factors that add up to 7. Obviously they need to be a factored pair, so 2 and 3, 1 and 6. We know that 1 plus 6 equals 7. Straightforward, I know, but we need to double check. Therefore, our y value is 6 and our z value is 1. This gives us x squared plus 7x plus 6 factorized down into x plus 6 multiplied by x plus 1. Using null factor law, we can then solve from this stage as we set that equal to 0, and then we'll either have x equal to -6 to make that first bracket set 0, or x is equal to -1. Looking at a second example, we have x squared minus 4x minus 12. In this case, our b is equal to negative 4 and our c is equal to negative 12. It's important to remember to include the negatives. Our factors of negative 12 are 1, 2, 3, 4, 6, 12, and their negative pairs, negative 1, negative 2, negative 3, negative 4, negative 6, negative 12. When dealing with negatives, sometimes you'll have to do a bit of addition and subtraction to get to that b value. So in this case, looking through our different factors, can you have a go at seeing what will add up to negative 4? In this case, our y value will equal negative 6 and our z value will equal 2, as negative 6 plus 2 gives us negative 4, which is our b value. Therefore, we have x squared take 4x take 12 is equal to x subtract 6 multiplied by x plus 2. Now, in both the first problem and this one, you can then remultiply out to double check your answer, going through the process of multiplying each bracket against one another. Using our null factor law to finish this one off and solve for x, we have x subtract 6 multiplied by x plus 2 equals 0. Therefore, x will equal 6 or x will equal negative 2, as this will solve either bracket pair for 0. Okay, our next one is x squared plus 4x plus 4. So we have b is equal to 4 and c is equal to 4 in this case as well. Our factors of 4 are 1, 2, and 4. In this case, to get 4 just by itself, for that b value, we'll have y equals 2 and z equals 2. This will give us x squared plus 4x plus 4 is equal to x plus 2 multiplied by x plus 2. We can simplify that down further, as this is what's known as a perfect square. So we just have x plus 2 squared, as it's just itself multiplied against itself. Given that equal to 0, we can see that x is equal to negative 2. Our final example for these straightforward factorizations is x squared plus 8x subtract 9. So our b value is 8 and our c value is negative 9. Our factors of negative 9 are 1, 3, 9, and their negative pairs, negative 1, negative 3, negative 9. To get 8 by itself, we'd be looking for a 1 and a 9, and because it's positive, we'll have y equal just 9, positive 9, and z equals negative 1. Therefore, we have x squared plus 8x subtract 9 equals x plus 9 multiplied by x minus 1. Applying the null factor law, we have x plus 9 multiplied by x minus 1 equals 0. Therefore, x equals negative 9 or x equals 1 to solve each bracket. Now, sometimes quadratics also have an a value, that is, a value in front of the x squared. For this process, you'll follow the following steps. You need to multiply your a and c value. You then find factors of ac, or a multiplied by c, that equal b. In this example, we'll also call these y and z. You then split bx and then factorize via grouping. So what I mean by split is, if you look below, we have ax squared plus y plus zx. So you split that b into the y plus z. Plus c is then equal to ax squared plus yx plus zx plus c. From there, you can factorize down into groups and then solve the equations. So let's look at some real examples, and hopefully that'll clear up any confusion. Our first one is 3x squared subtract 5x plus 2. So our a value equals 3 and our c value equals 2. Therefore, AC is equal to 6, remembering that AC is a multiplied by c. As we wish to get to negative 5, which is our b value in this equation, we will need to have y is equal to negative 3 and z is equal to negative 2. remembering that negatives multiply together to give a positive. So negative 3 multiplied by negative 2 gives us our 6 value. We then write this out. So we have 3x squared subtract 5x plus 2 will now equal 3x squared subtract 3x subtract 2x plus 2. You'll see this is the exact same equation. We've just split it up further so we can then factorize much easier. Therefore, we have 3x multiplied by x take 1. As you can see here, in the first two steps of this equation, I have taken out 3x, as we had 3x squared take 3x. Taking 3x out of both of them leaves x minus 1 multiplied by that 3x. We then have subtract 2 multiplied by x take 1. So this is those final two steps of the equation where I have taken out negative 2. We had negative 2x plus 2. So taking out negative 2 from the first bit leaves x, and from the second bit leaves negative 1. Again, remembering two negatives make a positive. We then pull out the two different parts. So we pull out the 3x minus 2, and we put that in our first bracket, and the x minus 1 becomes our second bracket, because we had that 3x and that negative 2 multiplying x minus 1. So we are left with 3x minus 2 multiplied by x minus 1. Setting that equal to 0 once more, you would get x is equal to 2 over 3, or 2/3, or x is equal to 1. Okay, another example now. We have 13x squared, take 7x, take 6. So a equals 13, c equals negative 6. So our AC, our a multiplied by our c, equals negative 78. Now, for looking for factors that add up to 7, I would use a calculator for these ones and just have a bit of a play around with what works and equals negative 78. Hopefully, remembering that you need to equal that b value. So in this case, we'll end up with negative 13 for our y value and 6 for our z value, as negative 13 plus 6 gives our negative 7, which is our b value in this equation. And 13 multiplied by 6 gives 78, so negative 13 multiplied by 6 gives negative 78. So then rewriting our equation, we'll have 13x squared subtract 13x plus 6x subtract 6. In those first two steps of that equation, 13x squared take 13x, we can take out 13x and we're left with x minus 1. And in the second two steps, we have 6x minus 6. So we can take out 6, which leaves us with x minus 1, which then simplifies down to 13x plus 6 multiplied by x subtract 1, because the 13x and the plus 6 are both multiplied by x minus 1, so we can group them together and separate out the x minus 1. Applying null factor law, we'd have x is equal to 6 over 13, or 6/13, or x is equal to 1. Okay, another example now. 2x squared plus 5x subtract 12. So we have a is equal to 2, c is equal to negative 12. So our AC, or a multiplied by c, is equal to negative 24. We then have y is equal to 8 and z is equal to negative 3, as 8 subtract 3 gives us our positive 5, which is our b value. Placing that back into the equation, we end up with 2x squared plus 8x subtract 3x subtract 12. That first two steps, 2x squared plus 8x, hopefully you can see we can take out 2x from both, leaving us with x plus 4, so 2x multiplied by x plus 4. And in the second two steps, well, 3 goes into 3x and 12, so we'll take out negative 3 in this case, and be left with x plus 4 as well. Combining those two parts of the equation now, we'd have 2x subtract 3 multiplied by x plus 4. Once more, to solve for that x value at the end, we apply the null factor law and are left with x is equal to 3 over 2, or x is equal to negative 4. Final example now for these ones. We have factorise 9x squared plus 9x subtract 10. So our A value is 9, our C value is negative 10, which makes AC, A multiplied by C, equal to negative 90. So therefore we have Y is equal to negative 6 and Z is equal to 15. Again, playing around with those bigger numbers in your calculator, and eventually you'll find some factors that are equivalent and add together to equal 9. So in this case, 15 subtract 6 gives us our 9 value. Writing out the equation with the changes, we have 9x squared plus 15x subtract 6x, take 10, which then groups down those first two parts being divisible by 3x, as 3x goes into 9x squared 3x times, and goes into 15x 5 times. So we had 3x multiplied by 3x plus 5. We then have 6x subtract 10. We can see that 2 goes into both of those, leaving us with negative 2 multiplied by 3x plus 5. Grouping them back together, we have 3x subtract 2 is multiplied by 3x plus 5. Applying null factor to finish off, we have x is equal to 2 over 3, or x is equal to negative 5 over 3. Sometimes factorizations of quadratics require a few more complex calculations. One such technique is known as completing the square. To do this, we start with our standard form, ax squared plus bx plus c, and we add b over 2 squared and balance this out by subtracting b over 2 squared as well. This will give us a perfect square, which is when it factorizes down to just one term or one bracket set squared by itself. And we then simplify the other terms included. We then apply a squared subtract b squared is equal to a plus b multiplied by a minus b, if appropriate, as sometimes completing the square can lead to incomplete factorizations. So looking at the example below with just the text and our unknown variables, we'll end up with ax squared plus bx plus b over 2 squared subtract b over 2 squared plus c. Now that sounds like a lot going on, so let's look at it again with some actual numerical examples. So in our first example, we've been asked to factorize x squared plus 4x plus 1. So given that we're going to be completing the square here, we know that b is equal to 4. Therefore, b over 2 squared is going to be equal to 4, because 4 divided by 2 is 2, and 2 squared is equal to 4. Placing this into our equation, now you'll notice in both the variable example I said before and the example here, we add the 4 and subtract the 4 before the final coefficient. This is because in the next step, it'll simplify down those first 3 terms. So we have x squared plus 4x, then we add our extra values in, so plus 4, subtract 4, plus 1. We can then factorize, the perfect square there. So then we have x plus 2 squared, subtract 3, because we have collected that negative 4 and that plus 1. Our next step is we have x plus 2 squared, subtract the square root of 3. Now, the square root of 3 squared gives us 3, which means we end up with a formula that has our a squared subtract b squared. In this case, our a squared is our x plus 2 value, and our b is the square root of 3. So we can then write that out as x plus 2 plus the square root of 3 multiplied by x plus 2 subtract the square root of 3. And that is how you complete a factorization, by completing the square. Now, we can apply null factor to this final step, making the whole equation equal to 0, and get that x is equal to the square root of 3 subtract 2, or x is equal to negative the square root of 3 subtract 2. You can write this out in decimal form if needed, but leaving it in surds for the most case should be fine, unless the question asks otherwise. Let's look at another example now. We have x squared, subtract 8x plus 13. So once more, knowing we're completing the square, we look at our b value. So we have b is equal to negative 8. Therefore, b over 2 squared will equal 16, as negative 8 divided by 2 is negative 4, and when we square negative 4, we get 16, as a negative times a negative is a positive. Placing those back into our equation, we have x squared subtract 8x plus 16, subtract 16 to make sure we're balancing it out, plus 13. So we can see the first three terms form a perfect square. So we'll have x plus 4 squared, subtract 3. Then our next stage, we'll have x plus 4 squared, subtract square root of 3, which then using the simplify rule of a squared subtract b squared is equal to a plus b multiplied by a subtract b, we get x plus 4 plus the square root of 3 multiplied by x plus 4 subtract the square root of 3. Once again, at this stage, you can apply the null factor law, making your equation equal to 0, which gives us x is equal to the square root of 3 subtract 4, or x is equal to negative the square root of 3 subtract 4. Looking at a different example now, we have x squared subtract 8x take 5. So b is equal to negative 8. Therefore, once again, our b over 2 squared will equal 16. Placing that into the equation, we have x squared subtract 8x plus 16, take 16, subtract 5. Our next line, where we take the perfect square, in this case, we'll have x subtract 4, as you've got to be careful with what your b value is. As you remember, those two numbers need to add up to negative 8. So in this case, negative 4 plus negative 4. Remembering that negative 4 multiplied against negative 4 still gives us our positive 16, as two negatives make a positive. We then subtract the square root of 21. Now you'll see in this one, I skipped that extra step. Once you're a bit more comfortable with them, you can make sure you're doing it. Just make sure your layout is clear and you know which your step you're up to, as you don't want to make simple mistakes by trying to rush through a problem. Therefore, once again, we have x subtract 4 plus the square root of 21 multiplied by x subtract 4 minus the square root of 21. Applying null factor law, we get x is equal to square root of 21 plus 4, or x is equal to negative square root of 21 plus 4. Okay, our final example now, we have x squared plus 10x, subtract 4. So our b value will equal 10 in this case. Therefore, b over 2 is 5, and 5 squared is 25. So our b over 2 squared is equal to 25. Placing that back into our equation, we have x squared plus 10x plus 25, subtract 25, subtract 4. Again, incorporating both lines into the next step, we have x plus 5 squared, subtract the square root of 29, which gives us x plus 5 plus the square root of 29 multiplied by x plus 5, subtract the square root of 29. Which leaves us with, once applying the null factor law, x is equal to square root of 29, subtract 5, or x is equal to negative 29, square root that is, subtract 5. There is a simpler way to solve quadratics using what's known as the quadratic formula. This formula is derived and allows us to solve for our values of x without having to use the null factor law and does not require any factorization. Some may find this easier, others find null factor law much easier to comprehend. I personally find this easier and feel like it's a quicker way of doing it without having to factorize. So, our law, again using our base quadratic equation, ax squared plus bx plus c, our quadratic formula is x is equal to negative b plus or minus the square root of b squared take 4ac over 2a. The key bit of this equation is the plus or minus, because that means you actually have to use this equation twice for each sum, as it'll give two answers, much like the null factor law. Let's look at some examples and substitute our numbers in. So we have x squared plus 7x plus 6 equals 0, and we've been asked to solve it. Now, if you've watched through the factorization parts of the video, you know we've already done this one with null factor. You'll see here we get the same answers. It's just another way of solving the equation. So our a value is 1. Remembering if there's nothing in front of a letter in algebra, it's just 1. Our b value is 7, and our c value is 6. So x is equal to negative 7 plus or minus the square root of 7 squared, subtract 4 multiplied by 1 multiplied by 6 over 2 multiplied by 6. Now, you should have access to your calculator to do these ones. You can do them in your head, it just takes a little bit longer, but I've just put it in my calculator. And you'll need to solve it once for adding and once for subtraction. So once for negative 7 plus the rest of the equation, and once for negative 7 subtract the rest of the equation. This will give you x values of negative 6 or negative 1. Okay, looking at another now. X squared subtract 4x take 12 equals 0. So our a value is 1, our b value is negative 4, and our c value is negative 12. Remembering it's important in this case to remember your negative values. So x is equal to 4 plus or minus square root of negative 4 squared. Now you have to be careful with those ones, as remembering a negative times a negative gives a positive, even when it's a negative squared. Take 4 multiplied by 1 multiplied by negative 12 over 2 multiplied by 1. Plugging that into your calculator away again, or solving it in your head if you can, that gives you x is equal to 6 or negative 2. Okay, looking at a more complex example now. Looking at one where our a value is not 1, we have 2x squared plus 5x subtract 12 equal to 0, and we're asked to solve for x. So our a is equal to 2, our b is equal to 5, and our c is equal to negative 12. So our x is equal to negative 5 plus or minus the square root of 5 squared, subtract 4 multiplied by 2 multiplied by negative 12 over 2 multiplied by 2. And this gives us our x value is equal to negative 3 on 2, or our x value is equal to negative 4. Last example now, using the equation. We have x squared subtract 8x subtract 5 is equal to 0. So our a is equal to 1, our b is equal to 8, and our c is equal to negative 5. Now, for an example like this, you'd usually need to use completing the square if you're factorizing, but we can just plug our numbers into the equation. So x is equal to negative 8 plus or minus the square root of 8 squared, subtract 4 multiplied by 1 multiplied by negative 5 over 2 multiplied by 1. Plugging that into your calculator, you'll get x is equal to square root of 21 plus 4, or x is equal to negative square root of 21 plus 4. Sometimes in mathematics, you'll be asked to sketch quadratics and other functions on the Cartesian plane. There are several strategies and tips that you can use to find the different parts of a quadratic and sketch it on the quadratic plane. Now, for this, we use the same formula, ax squared plus bx plus c. Remembering from our introduction to quadratics that a quadratic is shown as either a U or an N shape on the Cartesian plane. So, how do we find what that shape is? Well, if our a value, that is the value at the start of our equation, is greater than 0, then it will be U-shaped. This is known as concave up. If our a value is less than 0, then it will be N-shaped, concave down. Now, I've had people ask me before, what if a is equal to 0? Well, then it's not a quadratic because that x squared value doesn't exist, and it is simply a linear equation. Our c value allows us to find the y-intercept. Much like a linear equation, that plus c tells us where our line crosses the y-axis. To find where our line crosses the x-axis, you have to solve the quadratic. This is solving the quadratic either through factorization or through the quadratic formula. These are known as the roots of the quadratic. You then need to complete the square to find the vertex. This is what's known also as the turning point of the quadratic and is where the curve either turns around to go back up or turns around to come back down, depending whether it's concave down or concave up. Below, I've provided some diagrams that show what these different terms are and where you'll find them on a drawing of a quadratic on a Cartesian plane. So the one on the left being concave down and the one on the right being concave up, where their vertexes, y-intercepts, and roots are. So, without further ado, let's have a go at drawing one ourselves. So we're asked to solve x squared plus 7x plus 6 equals 0 and sketch. So, looking at our values, we have a is equal to 1, b is equal to 7, and c is equal to 6, which straight away tells us that our y-intercept is 6. I'm going to put a dot on the chart to the left where that will be. Now, as I said before, I prefer the quadratic formula than factorization, so I'm just going to plug all my numbers in, which will give me my x values, or my roots, equal to -6 or -1. So now I know that it's going to cross the x-axis at -6 and -1. So I'll place some dots on the chart there to indicate where that is. Final step is to find our vertex. So we have to complete the square. So my b over 2 squared value is 49 over 4. So I will place that into my equation. So we have x squared plus 7x plus 49 over 4, subtracting 49 over 4, as to balance it out we need to subtract it as well, plus 6. Now in this case I'm going to convert them into decimals because I find it easier to work with the decimals when I'm then drawing the quadratic. So I will have x plus 3.5 squared subtract 6.25. So that is completing the square and then adding the different terms that are outside that square. This gives me my two terms for my vertex, the x term being within the brackets, so -3.5, and the y term being outside the brackets, in this case being -6.25. So that gives me 4 points of my quadratic. I can then use those points where I have my roots, -6 and -1, my vertex, and my y-intercept. With my a value being greater than 0, I know it's going to be curved up. So then I just need to draw a parabola, or the curve of the quadratic, through those dots, and I have sketched my quadratic. Let's look at a second example now. We have -x squared plus 4x plus 12 is equal to 0. So we know a is equal to -1, b is equal to 4, and c is equal to 12, giving us our y-intercept of 12 straight away. Plugging those numbers into the quadratic formula, I get out x is equal to 6 or x is equal to -2. Then I need to solve my vertex. So in this case, my b over 2 squared is 4 over 2 squared, which equals 4. I'm then going to take the -1 out just to make it a little easier to solve for our equation. Just by removing -1 and taking that factor out of everything. So if you see, our positives have become negatives and our negatives have become positives. That gives us -1 and then in brackets x squared take 4x plus 4 subtract 4 take 12, which gives us -1 and then in brackets x minus 2 squared minus 16. Then removing the brackets for that 16 term because that sits outside of it, we can have -1 multiplied by x minus 2 squared plus 16, which gives us our vertex of 2, 16, or our x value is 2 from the brackets, and our y value is 16 from outside the brackets. Once more, we have our 4 points that I have now plotted on the chart, and we can connect them with a parabola to show our quadratic equation on the chart, with roots of 6 and -2, a y-intercept of 12, and a vertex of 2, 16. Thanks for watching. I know this was a lengthy one, but hopefully you now have a strong sense of how to solve quadratics, draw quadratics, and rearrange them in a multitude of different fashions. Thanks for watching, and we really hope to see you again soon.